Graph f of x equals secant x. Now, this is the very first time we're graphing secant, and what I want to do is I want to break things down as friendly as humanly possible. Secant is 1 over cosine. So the way you graph a secant is you use cosine as your rough draft. Okay, so what cosine does, gentle reminders for cosine, is cosine has a period of 2 pi. It starts out at 1, 0. And it repeats itself every 2 pi and so on and so forth. So let's graph 1 over cos x as our rough draft. All right, so looks like this. What do I have? 2 pi, so it's going to cross here. It's going to bottom out here. It's going to cross here. It's going to peak out here. So drawing a rough draft, this happens. Similarly over here, drawing a rough draft, this happens. Good. Now this is basically like my guide. Okay, this is my guide to draw secant because secant is 1 over cosine x. If you have an x in the denominator, that's no good because what that tells you is at some point you should expect vertical asymptotes whenever the bottom is going to equal 0. Now, when is regular cosine x equal to 0? Well, let's look down here. Cosine x, the rough draft, equals 0 whenever it crosses the x-axis. Now, what that means for us is that gives us vertical asymptotes for secant x. We're going to have a vertical asymptote wherever cosine x equals 0. So anytime my cosine x crosses the x-axis, my regular equation is going to have a vertical asymptote. So I'm going to draw vertical asymptotes wherever my cosine function crosses the x-axis, like so. Now, obviously, I haven't begun drawing my secant, but I'm getting there. Okay, one more step and I'm going to get there. All right, I know that secant looks like this, where you kind of have these parabola-looking things and they kind of take turns going up and down and up and down and up and down. Well, where do they begin? Well, first off, I know that secant x is going to equal specific things when cosine of x equals something like 1. For example, when cosine x equals 1, secant x equals 1. Okay, so if I could figure out where cosine x equals 1, that allows me to place dots on 1 for secant x. So it equals 1 here, it equals 1 here, and it equals 1 here. Similarly, if cosine x was -1, secant x would be -1, which allows me to put dots here and dots here. Now I have enough information to draw my actual graph, which is what I'm going to do now. Again, secant kind of follows this parabola-looking thing where it's concave up, then concave down, then concave up, then concave down. So I'm going to try to draw that. Concave up, now concave down. Concave up, now concave down. And last but not least, concave up. So again, what I did is I rewrote secant as 1 over cosine x, and I allowed that to be like my rough draft as to where things were. Now I know what's going to happen. Now I know wherever this 1 over cosine rough draft, wherever this cosine peaks out is where my secant begins. Wherever it crosses the x-axis is where I have a vertical asymptote. So as I do more problems and I start adding amplitude and phase shifts and stuff like that, I now know what this is going to look like. Okay? Secant x, pretty important and fun.